Example 1, for each relation below, determine whether the relation is a function, determine or identify the domain and range. We're going to look at A. A relation that associates the given shapes with the number of right angles in the shape. As some of us may be able to see, this is a function. This is a function because for each element of our first set, it maps into a unique, or it maps into only one element of the second set. So perhaps I'll take another go at this and maybe explain it in a different way. I think it's always useful to write out our set. So right now, I'm going to write right triangle, acute triangle. We have a square, we have a rectangle, and we have a regular hexagon. Right? So a relation that associates given shapes with a number of right angles. So right here, I'm just going to call this number of right angles. And I noticed that some elements in my second set, they'd have to include 0, 1, 4, and 0. Now notice that some elements duplicate, so we only need to write them down once though. So a right triangle has 1. An acute has 0. A square has 4. A rectangle also has 4, and a regular hexagon has 0. So what we see is that every element in the first set maps into one element of the second set. So is this a function? This is not a function. Sorry, incorrect. This is a function. The domain for this function now would be right triangle, acute triangle, square, rectangle, and regular hexagon. The range for this relation or this function are all the elements of the second set, 0, 1, and 4. So what we notice is that there's more elements. An indication that this may be a function is that we have more elements in the domain than in the range. Now, this doesn't tell us always when it is the case of when we have a function or not a function, but it definitely helps out. So, this next one, is this a function? 1, so I'm looking at B, 1 is the square of, well, 1 is the square of two numbers, -1 and 1. As soon as you see one element in the domain mapping into two elements in the range, this is not a function. So I can actually stop there and just say not a function. And further, 4 is the square of 2 and negative 2. Additionally, 9 is the square of negative 3. And what's not included is also 3. But regardless, it's not a function. But it still has a domain and range. My domain for this function is going to be 1, 4, 9. My range is going to be negative 3, negative 2, negative 1, 1, and 2. Now, whenever we have less elements in our domain and more elements in our range, this implies that it's always going to be not a function. Simply, we have to have at least one out of these elements that would map into 2 or more elements of the range, which would make it not a function. All right, is this a function? Well, I'm just going to put these in brackets here and see what happens. I have number of marbles and the mass. The relationship that exists is the mass or the number of marbles have a mass of one marble has a mass of 1.7 or 1.27. 2 marbles have a mass of 2.54. And indeed, what we see is that each element of the first set maps into only one element in the second set. So this is a function. My domain. My domain is 1, 2, 3, 4, 5, 6. My range is going to be 1.27, comma, 2.54, 3.81, 5.08, 6.35, and 7.62. All right, and that brings us up to practice. If you have any questions, make sure you ask.